Hello again, Algebra 1 students. Today our lesson finishes up section 8.5. This is our third day on factoring. Today we're going to factor trinomials that are in two variables and do a couple other applications with factoring. Now, sometimes we just want to factor a thing. We can't really solve it. This is one case. If you have a trinomial with two variables, notice this is in x and y, this can't be solved. We can't find a value for x or a value for y, but we can still factor this. So we factor this using the same or similar methods to what we did before. All right, notice that our first term is x squared and our last term is 14y squared. If we remember reverse foiling, if we have two binomials multiplied by each other, we know that the f, the first, is going to multiply to, these two terms must multiply to x squared. Well, there's only one way to make that happen. That would be x and x. And then we look at the sign of the last term, which is positive, which tells us that the two signs in our factors must be the same. And the sign of the middle term is also positive, so we know that these two signs must be plus. All right, now let's go to the last term. It's 14y squared. So whatever this term is multiplied by this term, that would be our L in FOIL, or our last, must multiply to 14y squared. So they each are going to have a y in the term. And then we just need to determine now the coefficient there. And now our method is similar to what we've used in the last couple lessons. We need two numbers that multiply to 14 but add up to 9. So 14 only has a couple sets of factors. 14 and 1 would add up to 15, or 7 and 2. So since they both are positive, it doesn't matter if we put the 7 first or the 2 first. And now we have two factors. We should always check our factoring by foiling, and when you get good enough at this, you'll be able to check this in your head. Maybe some of you can do that already, but if not, it only takes a couple of seconds to do the FOIL. First would be x squared. Outer, notice 2y times x would give us 2xy. Inner, 7xy. And last, 14y squared. Then we can combine our two like terms in the middle, and we would have x squared plus 9xy plus 14y squared. So we factored this trinomial in two variables into two binomials. This would be our answer right here. We checked it, and it checks out. All right, let's take a look at a couple other examples. Let's focus in on this example. X squared minus 5xy minus 24y squared. If you want to pause the video now and try this, if you're up for the challenge, I would say go for it. I will continue to work it here if you want to look. Two factors of x squared, x and x. Our last term is negative, so we need one positive and one negative. Well, I know that there will be a y in each term, and now I need two numbers that multiply to 24 but have a difference. Why a difference? Because they have different signs. A difference of 5, and that would be 8 and 3. I want a negative 5, so let's do negative 8 and a positive 3. Checking first, x squared, outer negative 8xy, inner positive 3xy for a total of negative 5xy, and last negative 24y squared. Okay, here's our last example. Again, I would suggest you pause right here. See if you can figure this one out. I always like to put my parentheses down first, factor the first term, look at my signs. Did you guess that they would both be positive? Two numbers that multiply to 6 and add up to 5. Don't do 6 and 1, it's got to be 2 and 3. Okay, just to reiterate, we could not set this equal to 0 and be able to solve this. You cannot solve one equation in two variables. All right. Moving on, we're going to start getting tricky with our trinomials when our leading coefficient is not a positive 1. I don't know if you've noticed this so far, but so far our leading coefficient has just been a positive 1 here. So we're going to start out really slow today. We're just going to look at what happens when our leading coefficient A is equal to negative 1. Why do I say A? Because the standard form of a quadratic, remember, is ax squared plus bx plus c. And that's how we denote the coefficients of the term. So when the leading coefficient is negative 1, your trinomial will look like this. Well, notice you've got 3 negative signs there. And the easiest thing to do is to just factor off a negative 1 from each term. So that would leave us with x squared plus 11x plus 18. And then now ignore the negative 1 out front, and let's just factor this trinomial. So we have a positive sign here, means that both our signs will be the same. Positive sign in the middle means that they will both be positive. And then ask yourself, what are two numbers that multiply to 18 and add up to 11? 9 and 2. And you can leave this just like that. You could multiply this negative 1 through there, but most of the time we'd leave it just like this. If this were set equal to 0, let me just take it one more step. What if we wanted to solve this? If this factor were 0 or this factor were 0, do you see how it would zero out the entire product? It doesn't matter if this is a negative 1 or 7 billion. 0 times 7 billion is still 0. So if we did have an equation that we were trying to solve here, we would factor off the negative 1, factor the trinomial, apply the zero product property. X plus 9 equals 0, x plus 2 equals 0, x equals a negative 9, x equals a negative 2. And I challenge you, put in a negative 9 here, put in a negative 2, and see how you get 0 for both of those. This negative 1 coefficient matters not to the answers. All right, one more example like that. If you want to pause and give it a shot, go ahead. Again, factor off the negative 1. We'd have x squared minus 14x plus 45. Keep the negative 1 there because it still is a factor. I've got signs that are the same. They are both negative. So I'm at x minus. Then ask myself, what are two numbers that multiply to 45 but add up to 14? Run through your factors. That's why it's so important to know your multiplication tables. This would be 9 and 5. And if we did not have an equation we were trying to solve, if we were just trying to factor this trinomial, this is where we would stop. All right, one application problem before you get your homework. Here's our application. Find the dimensions of this triangle. The base is represented by x plus 3. The height is x plus 1. If the area is supposed to equal 12. Well, we know the area of a triangle is 1/2 the base times the height. So we can just go ahead and fill that in. 1/2 x plus 3 times x plus 1. And this area, we want the area of the triangle to equal 12. Study that for a minute. Make sure that you feel comfortable with that expression. And then now we want to solve it. All right, I know I'm going to have a quadratic here. I don't like the fact of this 1/2. So what I'm actually going to do is I'm going to multiply both sides by 2. I can do that. And then I would, those cancel. And I would have 24 is equal to, let's go ahead and FOIL this. First, x squared, outer 1x, inner 3x for a total of 4x. And I would encourage you to learn how to do the outer and the inner in your head and add them in one step. Work towards that. Last, 3 times 1 is 3. If you remember the steps from yesterday, set your quadratic equal to 0. That means I'm going to have to subtract 24. And then I'm going to just kind of flip this over. So I have x squared plus 4x. 3 minus 24 is minus 21 is equal to 0. I'm running out of room. I'm going to go up over here. So let's factor this. My third term is negative. That means my signs are different. My first term is x squared. Now I need two numbers that multiply to 21 and have a difference of 4. I know some of you are very good at this. If not, gets easier with practice. 7 times 3 is 21. Positive 7, negative 3 is a positive 4. Hopefully you know what to do from here. X plus 7 equals 0, or x minus 3 is equal to 0. That's the zero product property. Solve each. X is equal to negative 7, or x is equal to 3. Now this is where we have to use some logic. Say, look at the context of this problem. X plus 3 stands for the length of the side of a triangle. Could x equal negative 7? If x were negative 7, we would have a length of negative 4. And that does not work in the context of this problem. So oftentimes in the real world, when you're using a quadratic to solve a problem, one answer just might not work in the real world. So we would say x is equal to 3. If we go back here, if x is 3, we would have a base of 6 and a height of 4. 1/2 6 times 4 is 24. Pretty amazing stuff. I hope you are amazed. Here's the homework, page 528. I will also list those in Google Classroom. Hope you all are well. Take care.